My science vision is sustainable spaceflight for the benefit of humanity now and in the future. My thesis goal is to set up a methodology how to completely assess the environmental impact of rockets. We do in our research a split between 3 different phases. The first one is the production phase, where we look at the production of the launcher and the propellants. And then the next phase we look at the launch emissions. And then in the end, when the rocket comes back to Earth in the atmosphere and it depletes there, what are the emissions coming from that? We need this analysis of those different phases for the future, that we can develop technologies that are more environmentally friendly than the current technologies are. So we do more or less only data research and simulation. For the data research, we started a project together with industry looking at the existing data on the environmental impact of production of launches. And now for the launch and re-entry emission part, I developed my own tools to simulate the emissions there based on a calculation model that uses the different atmospheric layers for the assumption of the final emissions. The most surprising findings from my thesis are so far that the production has a very significant impact if we compare it to the launch and re-entry part. You have to produce the alloys for the launcher, aluminum, steel, titanium. And then on the other side, you have also the production of the propellants, which is also very energy intensive because you need to cool them down to 20 Kelvin or 90 Kelvin for oxygen. And this needs a lot of energy that is currently mostly run by fossil fuels. Of course, for the launch and re-entry emission phase, we won't be able to lower the emissions because we need to go up in space somehow. But the question is, which propellant is the most sustainable? During my work at the University of Stuttgart, we also had a research project together with the EPFL in Lausanne. And we developed there a tool to do those comprehensive life cycle assessments. And this was funded by the European Space Agency, is now a spin-off at EcoDelta-V, a startup based in Switzerland, where I'm also part of. Together with 2 co-founders, we further developed this tool for space industry to offer it as a service that they can do life cycle assessment for their products. My motivation for launching this business was mainly that we already had an existing tool that can now be used in the future by industry. That also the work that we do here at the university has also an impact in industry. And in the end, it has a very positive impact by reducing the environmental impact of the space industry. The university has a very big faculty of aerospace and geodesy here at the university. We have at our institute about 150 researchers with 4 full-time professorships. Those people are working in very different areas. So we have people working on satellite instruments, robotics, astronautics and exploration, and also the group that is now working on mission and system analysis that I'm part of. Yes, so it was a childhood dream for me to study aerospace engineering, which I also did here at the University of Stuttgart, and then later becoming a research in aerospace field. And also for me, it was a dream one day to fly into space. Let's see how it develops in the future. Maybe we can do this in the future in a sustainable way.